Children, today we are going to understand the concept of inverse proportion. Let us consider an example. Suppose your teacher has given you a piece of project to be completed and you are two children together. Now she tells you to do the project quickly. So what are you going to do? You will obviously increase the number of people in the group. So as soon as you increase the number of people in the group, the less time you will take to complete the project. But when you were less children together, then more time was taken to complete the project. This means that as we are increasing the number of children for the project, the time is getting reduced. And as we decrease the number of children in the group, the time will increase. Let me give you another example. Now, suppose you are again cycling. So, if you cycle at a high speed, then you will complete up your distance in less time. Whereas, if you cycle at a low speed, then you will take more time to complete the distance. This means that when the speed increases, time will reduce, and when the speed decreases, time will increase. So this type of a variation where one quantity increases and the other decreases, or one quantity decreases and the other increases, is called as inverse proportion. So let's say x and y are in inverse proportion. So when you increase the value of x, y will decrease. Like when you were increasing the speed, the time required to cover the distance was decreasing. And when you decrease one quantity, the other one will increase. That means if you decrease the speed of the cycle, then the time will automatically increase. You will require more time to cover the distance. So this type of a proportion where you go in the opposite manner means an increase in one leads to an decrease in the other, or a decrease in one quantity leads to an increase in the other, is called as inverse proportion. Now here the two quantities are in proportion such that the product of their corresponding values remains the same. Okay, so this value will always remain the same. So when I say x and y are in inverse proportion, they will be written as x is proportional to 1 upon y. Therefore, the value of x will be ky. So k will be equal to, y will go in the numerator, that is xy, where you all know that k is the constant of proportionality. So for as many values of x, like x1, x2, x3 and so on, and as many values of y, like y1, y2, y3 and so on, their products will always remain the same. That means x1, y1 will be equal to x2, y2 will be equal to x3, y3 and so on. So the formula for inverse proportion is x1, y1 is equals to x2, y2. Now let us start with exercise 13.2. Question number 4. If a box of sweets is divided among 24 children, they will get 5 sweets each. How many would each get if the number of children is reduced by 4? Children, as in the video of direct proportion, we have already discussed that these type of questions will always be written in the form of a table. So here again we have made a table where we are going to put all the information given to us. So here the information given is the number of children and the number of sweets each child gets. So number of children we are considering it as X, and the number of sweets each child gets we consider it as Y. So for 24 children, sweets are 5. Now we have to reduce the number of children by 4. So that means 24 children, when you reduce it by 4, you get 20 children. And for 20 children, you have to find the number of sweets each child will get. So as children, if the number of child decreases, then the number of sweets each child will get will obviously increase. So therefore, we can say that they are in inverse proportion. So we apply the formula x1 y1 is equals to x2 y2. Now substituting the values, you get 24 into 5 is equals to 20 into y2. 20 is in the numerator of the right hand side, so it will go in the denominator. After cancellation, the value of y2 is 6. So each child will get 6 sweets. Now the next question, children. A farmer has enough food to feed 20 animals in his cattle for 6 days. How long would the food last if there were 10 more animals in his cattle? Now here again we have to put the given quantities in the form of a table. So here the two things given to us are the number of animals and the number of days the food will last. So we'll consider X as the number of animals and Y as the number of days. So for 20 animals, the food will last for 6 days. So these are the values X1 and Y1. Now they are saying that if there were 10 more animals, 10 more animals means 20 plus 10. So the number of animals becomes 30. Then now for how many days will the food last? So X2 is 30 and Y2 we have to find. So you know that if the number of animals will increase, then the number of days the food will last will decrease. So again they are in inverse proportion. So therefore we apply the formula x1 y1 is equals to x2 y2. So therefore 20 into 6 is equals to 30 into y2 it becomes after substitution of the values. Again 30 will go in the denominator. After cancellation, you will get y2 is equals to 4. That means the food will last for 4 days. Now let's come on question number 9. A car takes 2 hours to reach a destination by traveling at the speed of 60 kilometers per hour. How long will it take when the car travels at the speed of 80 kilometers per hour? So here the two quantities which are given to you are time and speed. So we'll consider the time in x and speed as y. So for 2 hours the speed was 60 kilometers per hour. So the value x1 will become 2 and the value y1 will become 60. Now if the speed has increased to 80 kilometers per hour, then how much time will it take? So here the time which we have to find is x2 and the speed 80 kilometers per hour is y2. So as you are increasing the speed, children, the time will be reduced. So in this case they will again be in inverse proportion. So we apply the formula x1 y1 is equals to x2 y2. So after substitution of the values, you will get 2 into 60 is equals to x2 into 80. Again, this 80 is in the numerator. On the other side, when it goes, it comes in the denominator. So after cancellation, you will get the value of x2 as 3 by 2 or 1.5. 1.5 hours is nothing but 1 hour and 30 minutes. So the car will take 1.5 hours or 1 hour 30 minutes to reach the destination. Now let's come on question number 11. A school has 8 periods a day, each of 45 minutes duration. How long would each period be if the school has 9 periods a day, assuming the number of school hours to be the same? So here the two quantities given are the number of periods and the time duration. So we consider the number of duration as x and the time duration of each period as y, which is in minutes. So for 8 periods, it takes 45 minutes each period. So x1 will be 8 and y1 will be 45. And for 9 periods, you have to find how long will each period go in case the number of periods has increased to 9. So that means we have to find the value y2. So as you know, if you're increasing the number of periods, then the time duration of each period will decrease. So therefore, one quantity is increasing, the other one is decreasing. So they are in inverse proportion. So we apply the formula x1 y1 is equals to x2 y2. Again, after substitution, you get 8 into 45 is equals to 9 into y2. Now 9 is in multiplication. It will again go down in division on the other side. So after cancellation, you get the answer y2 is equals to 40. So each period will be of 40 minutes when the school has 9 periods a day.